Hello, everyone. Great to meet you all as part of this event. As you know, this pandemic has transformed the engineering landscape for the last 2, 3 years, right? So, the priorities of the enterprise have changed. How they are spending in engineering has changed. Some of the spend got optimized, and newer areas of spend started emerging. To set the context for this event, in this first session, what we want to do is we want to take a quick look at the overall engineering market and see some of the next-gen engineering trends that are driving growth in the market. Now, as you can see here, we at Zinnov, we track the global engineering and R&D market. We look at all the enterprises who are investing in the R&D spend, and what we see is that it's a $1.6 trillion market, and it's been growing, right? The pandemic did have an impact in this spend. In 2020, there was a muted growth, but if you see 2021, the overall engineering market has grown by 8%. Companies continue to invest in engineering and R&D areas. Now, this growth is even faster than IT spending that is happening within enterprises. So we see a lot of companies investing in this space. There are high-tech verticals like software, there is semicon and multiple verticals, high-tech verticals, which are driving the spend. And there are a lot of services verticals like your BFSI, healthcare. These are driving the spend, engineering spend as well in terms of platform engineering, in terms of the core engineering spend. In the manufacturing verticals, we saw a slight dip in 2020, but now we see a rebound. And as the industries like automotive, aerospace, and traditional engineering verticals are also coming back, and they are showing good signs of recovery post-COVID. If we take a closer look at this spend, there are two broad categories of spend. One is the legacy engineering spend, which most of us would know of, and the other one is the digital engineering spend. The legacy engineering spend has sort of remained stagnant, but what enterprises are doing here is they are looking at how we can optimize the spend. How can I enhance my sustenance of my products, and how can I extend the life of my mature products? So this is on the legacy engineering. And what they're trying to do is they're optimizing the spend here and diverting towards a lot of digital engineering areas. If you see digital engineering, these are driven by a lot of these new technologies, and that is driving the spend. The digital engineering market, the spend grew by 17% last year, and it is expected to drive growth future over the next 4 years as well. Now, what are the areas that are driving the spend? So what we've seen is a lot of next-gen engineering teams, broad teams, where enterprises are investing heavily to secure their growth. We did an analysis of top 1,000 engineering and R&D spenders globally, and what we found is there are 5 major themes where we are seeing a higher traction of spend in the digital engineering areas. So we are seeing that those 5 areas picking up. The first area is cloud engineering and AI, and the next we see sustainability engineering, and then we see digital thread, and the fourth aspect we see is 5G, and the fifth aspect we see is semicon or silicon engineering. This is more of a horizontal, which is spread across multiple verticals, right? Obviously, there are more emerging areas as next-gen engineering areas that are available. The market is focusing on. Here today, we will take a brief look at these 5 trends and what is happening within each of this. The first, if we look at the cloud or AI, what we see by 2025, cloud and edge computing use cases will be prominent across enterprises. We see more than 75% of the enterprise-generated data would be processed by cloud or edge computing. A lot of smart connected devices, platforms on cloud will be a mainstay in the industry, and it will continue to drive a lot of digital engineering and spend. The next aspect, which is gaining huge traction in the recent years, is sustainability engineering. So this focus on sustainable engineering, this could make or break the global consequences of global warming over the next 2 decades. So we are seeing a high traction in sustainability adoption, one due to the consumer preferences and other due to the investor push. So we are seeing a lot of push on ESG and other areas where there is an increased focus on sustainability. From an engineering standpoint, there are two larger pillars for sustainability engineering. One, how can we create sustainable products? How can we create products that are smart, recyclable, and environment friendly? That is one area. And the other area is how can I make sustainable operations in engineering, be it a shop floor or factory? How can I reduce the carbon footprint and enhance energy efficiency? These are the focus areas. So we are seeing multiple use cases like smart distribution, smart meters, battery and battery storage type of use cases. We are seeing carbon neutral energy generation. These are multiple use cases that are gaining traction within sustainability. For an example, if you see automotive R&D spend, out of the total R&D spend that went into automotive last year, nearly 35 to 40% was towards sustainable electric vehicles or sustainable modes of transport. So that is where the enterprises are spending their dollars in newer emerging areas. So we are seeing battery management systems, e-motors, power distribution. Multiple of these trends are emerging within each verticals. So sustainability engineering, we are seeing a huge traction, and it is expected to continue. The third element that we see is digital thread. When we say digital thread, this is across the entire product value chain, be it a smart design of the product or smart manufacturing or smart tracking of the product or smart insights or smart servicing. We are seeing across this value chain, digital thread is permitting. There are multiple use cases. We are seeing factory automation, asset monitoring, and smart warehouse. Multiple use cases we are seeing emerging under digital thread. But to start with, the automotive vertical is leading from the front, and some of the smart manufacturing use cases are having higher traction in the digital. The next trend that we are seeing is 5G. Yes, 5G took a backseat in terms of public 5G rollouts due to the pandemic, but we are seeing a wider traction in 5G picking up. A lot of companies are investing in 5G. The enterprises across the value chain are coming together, forming joint GTM partnerships and creating solutions, be it CSPs or equipment providers or enterprises. They're all coming together and creating joint solutions across these use cases. And we are seeing a lot of private 5G use cases gaining traction across various industries, be it AR/VR specific use cases or autonomous driving specific use cases or various EMBB use cases. So where enterprises are focusing on is use cases where there is a high ROI. So that has been the focus of in private 5G. Whereas we're also seeing a lot of telco players working on areas such as O-RAN, edge computing, network slicing, and they're working across various features enabling the entire 5G landscape. So we continue to see 5G as a major trend as a next-gen engineering area. The fifth aspect that we see is semicon engineering. So we might be wondering, semicon is more of a vertical, how it is a trend. What we are seeing is semicon engineering is quickly evolving to more as a horizontal, spreading across multiple verticals. We are seeing traditional end customers of semicon companies, be it an automotive company or a medical devices company or a high-tech companies like Apple, Meta, Tesla. All of them, or most of them, are creating in some custom chipsets or working on some customization of the chipsets or creating some in-house chip design capabilities. This is a trend which is picking up and it is expected to continue. For example, Tesla, if you've seen their autonomous cars, their autonomous driving feature is from their own chipsets, FSD. They call it as FSD as the first version, and there have been multiple iterations post that. But what they are trying to do is to create the chipset from the core so that it optimizes their algorithms performance. So we are seeing a lot of enterprises are picking on this trend to create customized chipsets for better performance. And we see, as part of this trend, nearly 200 billion is invested last year across semicon engineering activities in multiple verticals. Just from the non-semicon, Outside of the semicon vertical itself, there is 75% of the spend coming from. So we see software as a vertical where there are chipsets being created, consumer electronics, telecom, medical devices, industrial vertical. A lot of this embedded and pre-silicon or post-silicon spend is picking up across industries. We expect this trend to continue dominate the spending. So in a nutshell, these are the 5 trends, next engineering trends, which we're seeing in the market across verticals. Obviously, there are more next-gen trends, which are specific to verticals and across verticals as well. We are seeing enterprises building chip capabilities, cloud, and sustainable engineering capabilities. However, not all of the skill sets is in-house. Some of the skill sets are new to them, and there are some market challenges. But what we are increasingly seeing is the ecosystem coming together, working together to address these challenges. Over the remaining couple of sessions, we will hear from the industry experts on how this is playing out in their particular industries and how the engineering landscape itself is getting transformed. Looking forward to the session. Thanks everyone. Over to you, Natalia.